Hello, welcome to my class. Today I would like to show you a famous data set. It's popularly known as PIMA Indian Diabetes Dataset. Now I will share the complete solution of KAGGLE, and I hope all of you enjoyed Holi, and it's a gift to my students. So enjoy KAGGLE, and today I will show you how to cross the accuracy of the KAGGLE, because KAGGLE solved the PIMA Indian Diabetes dataset with the highest accuracy is almost 90.6%, and I achieved 92%. That is more than this accuracy achieved by KAGGLE. So let us come to the solution. So this is the solution. I will use this Jupyter notebook. You will get this Jupyter notebook the, you can download the Jupyter notebook from the Kaggle, sorry, from the GitHub, and you can go through it, you can run it. So let us check. There is, first of all, Vincent Lugat. Now, in his Kaggle contributions, achieved 90.6% accuracy using K nearest neighbor, that is KNN, and a very popular machine learning algorithm that is known as LightGBM. LightGBM. So uh, to Kagglers, the extreme gradient boosting and LightGBM is very, very popular. And you will find, close contents between this extreme gradient boosting and the LightGBM. So in this tutorial, I modified the approach of Vincent Lugat, and at the same time I used the different alternative approaches like the bagging, then a voting classifier, support vector machine with GridSearchCV, RandomForest Classifier with the GridSearchCV, extreme gradient boosting classifier. The latest algorithm of Stanford is NGBoost Classifier, LightGBM Classifier, AdaBoost Classifier, weighted average, and very popular approach, stacking. Stacking is nothing but it's an ensemble approach. Now, literature review shows that earlier researchers got 78 to 81%. One of the peculiarities of PIMA Indian dataset is its hidden pattern of the data. So the literature confirms that is you can easily get 78 to 81% accuracy. So Vincent Lugat is the first person who showed yes we can achieve 90.6% accuracy. And after Vincent Lugat, I got 92% accuracy, and today I will show you that you can expect to get more than 92% accuracy if you follow the same step. Now in this tutorial, I referred such constraint approach. This constraint approach is basically the rule-based approach proposed by Vincent, and I will show you what is this rule, for what reason we are using the rule, etc. Now I have used the different approaches like this XGBoost, extreme gradient boosting classifier, and I got 90% accuracy. LightGBM classifier, I got slightly higher accuracy, that is the 91% accuracy. And weighted average and stacking gives almost 91% accuracy. But one simple approach is, you know, it can yield about the 92% accuracy. So what is this? What is this approach? So let's see. Let us try to understand the PIMA diabetes dataset. Now in this diabetes dataset, you will get several fields. So let us try to understand the fields. Number one is preg PREG, that is number of times pregnant. PLAS, that is plasma glucose concentrations of a 2 hour in an oral glucose tolerance test. Praise, that is the diabetes blood pressure in millimeter, it's given mercury. Scheme, triceps spleen fold thickness test, that is the 2 hour serum insulin test. The unit is also given. The mass, that is the body mass index. PEDI is basically the diabetes pedigree function, and age in years, and the class variable, that is one is for tested positive for the diabetes, and zero is the tested negative for diabetes. So it is basically the data set, we are getting the two levels, 0 and 1. So we can consider this PIMA Indian diabetes is nothing but a binary classification. Okay. So this is the import sections. In this import sections, I am importing this numpy, then I'm importing pandas. Why I'm importing this pandas? I need to load the dataset. The dataset is .csv format, and then I am importing different algorithms. That is, number one is sklearn. From this sklearn's ensemble, I am importing this bagging classifier. From sklearn tree, I am importing decision tree classifier. From sklearn.metrics, I am importing confusion matrix, confusion report, and accuracy score. As usual, I am importing this matplotlib.pyplot as PLT. For plotting purposes, I'm also importing cbone as SB. SB means there's an acronym. Then next, I'm importing, you need to split the training dataset and the tracing dataset that you can get from the sklearn.model selection, model underscore selections. For support vector classifier, I'm using the sklearn.sbm, import sbc, sklearn.linear underscore model. I'm importing logistic regressions, sklearn.ensemble. I'm importing a random forest classifier, sklearn.naive underscore base. I'm importing Gaussian naive base classifier, sklearn.ensemble. I'm importing voting classifier. Then since I'm using this SBC, the support vector classifier, so I need to, normalize the data set. So that's why I'm using this pre-processing of this sklearn. So from sklearn.pre-processing, I'm importing standard scalar, and at the same time I'm importing XGBoost as XGB. Okay, so first load the data. So what you need to do, you just use pandas.readcsv. Just mention the name of the .csv file, so you can load it. Once you load it, then you show, that is, what is the content of the data set. Okay, data frame.head. So it will show by default the 5 rows. So 5 rows you can check here. This is the, the format or the table given to you. This table is nothing but the data set. Data set is basically the PIMA Indian Diabetes .csv. Okay. Now what I'm doing next, I'm taking this means showing this info. This data frame.info is basically, all these data type, all the data type I'm showing, that is a particular field, that is the pregnancy, what type of data type, glucose, what type of data type, blood pressure, what type of data type, then BMI, what type of data type, there's diabetes, pedigree function, what type of data type, age, what type of data type. So if you check, it's basically, it's having this integer 64 integer data type and float data type, means basically the numeric data type. There is no non-numeric data type. Then you can print, that is the how many number of rows and number of columns you have. That is, it has a 768 number of rows and 9 columns. Now the next thing is the data imputation. The two approaches you can use for the data imputations are the two different approaches I will show you. The first one is you write a function, and your objective is, if you find a particular data, then you have to impute it. You need to replace it with the median, with the value of this median. So what I'm doing, so I'm considering, I'm defining a function, define call underscore median. So I'm taking a data frame corresponding the target column and the variable, all the list of variables you are considering. So from that, I am taking, not null values. So what I'm doing, data frame, I'm filtering it, data frame var, all the name of the variables, dot not null, and I am assigning it to a temporary value, temporary data frame. And then what I'm doing, I'm saying that is I need to group all the variables by its median. Then I need to reset the index. So what I'm doing, so temporary variable, this is this variable. Then I am passing the var. The var is the all the variable columns and the target column. And then what I am doing, I'm saying group by. Then group by. Then what I'm giving the name of the target column. And then what I'm doing, I'm passing the variable, and then I'm taking this median, I'm reset the index, I'm returning the temporary variable. Now next, what I'm doing, once you are calculating the median, next I need to import it. So I am defining another function, that is diff median underscore imputations, taking a df, the data frame, target column, var, that is the all the variable var 0 and var 1, and these are the list of arguments. And what I'm doing, I'm saying before I in range length of data frame colon if data frame dot log I comma target is equal to 0 and data frame dot log means the locations, the I comma var is equal to 0, then data frame dot log I comma var is equal to var underscore 0. If data frame dot log I comma target is equal to 1, data frame dot log I comma var is equal to 0, then data frame dot log I comma var is equal to var 1. So what is the meaning of it? Now, you know that is in target column we have the two levels 0 and 1. So based on this, I am just imputing this value. So let's see how I am calling it. So call median, the function, it has this value data frame. The data frame already, it's you have loaded the what is called the PIMA Indian Diabetes Dataset, and you pass it to the pandas data frame, and pandas data frame assigned it this value to a variable df. Now here you will get the df value. Now what is this first assign means first target means the outcome. This outcome contains because it is a classification problem. This is a supervised learning problem. So in this case, what you will get a target column in the target column. Because it is a classification problem, in this case you will get the discrete value. So here the values are 0 and 1. So two classes you are considering. It is a binary classification problem. So here you are getting this outcome. Okay. So the next is which column value you want to impute. That is this insulin. So once you are calculating this median, so here you will get 0, 0. How many values are there in this insulin? Means in the table in the data set you have see certain number of zeros and certain number of one in the target column, and the corresponding these insulin values you are having. Okay, so what I'm doing, I'm grouping it, I'm finding out how many rows you have in the data set that belongs to class 0. So you are getting 39. How many of them belongs to 1? You are getting 0. Okay. Now the next thing is you need to impute the median value. So what you need to do, you just mention the data frame, okay, df, then the target column outcome, then where you want to do this imputation, that is this insulin, then d dot log, you pass the 0 value, d dot log 0, because d is, see the calculate median, you are passing this value to this d. So d dot log 0, this d dot log 0, 0 rows, and the corresponding value is insulin is 39, and d dot log 1, that is second row, first row, second row, and the corresponding value is insulin. If you pass to this argument, that is median imputations, so it will impute the value. Okay, the same way what I'm doing, I am doing it for this glucose. I'm inputting this median value. I am doing it for the skin thickness column. I am doing it for the blood pressure column. I am doing it for the BMI column. Okay. Now this approach you will get from this KAGGLE itself. Vincent Lugat, he followed this approach. So I showed it the same thing here. Okay. I changed a little bit of. Now what I'm doing next, there is an alternative approach. So alternative approach is very simple. You just do this data frame You just mention the name of the column is glucose dot replace. So what value you are having is 0. So you replace the 0 value with numpy.nan, N-A-N, and you just make it in place true. So it will be effective. If you don't write in place true, then what you have to do? So data frame within a third bracket, just mention for inverted comma glucose is equal to data frame glucose dot replace 0 comma numpy.nan. Then it will be effective. Now the same way, the next step what you have to do? So data frame glucose dot replace numpy.nan. Then what you have to do? Data frame dot glucose. What value you want to transfer? The median. So dot median, okay, comma in place is equal to true. So it will be effective. And you apply the same. So two line approaches you need to do with the replace command. So you need to apply it for the blood pressure. You need to apply for the skin thickness. You need to apply for this insulin, and you need to apply for the BMI. Okay, cool. So the next one is what I need to do. I am just calling the plotly. Why I am calling the plotly? Because plotly is interactive. So import plotly.xpace as exp, import plotly.io as pio, and then what I am doing, I'm considering a function data frame plot underscore data. So I am passing this variable name data frame. These are the arguments, the data frame, comma, variable x, variable y, and target. So what I am doing, so pio.templates.default. Now I am passing the parameter simple white, so the background you will get this white. exp, that is the plotly xpace, dot defaults dot template is a ggplot2. Then exp dot defaults dot color continuous scale. This is equal to exp dot colors dot sequential black body. Then what I am doing, I'm just mentioning this width and height, that is exp, that is the plotly xpace dot defaults dot width is equal to 800. exp dot defaults dot height is equal to 600. Then what you need to do, you need to plot this scatter plot. So figure exp dot scatter, then pass these parameters like data frame, x is variable x, y is variable y, color is equal to target. Okay, the target column depending upon the target column level, so it will create the two colors. So figure dot show. Now what I am doing, I am calling the function. Now this function is plot underscore data. This function I am calling, passing the arguments data frame, comma, glucose. This glucose is along x variable, age along y variable, then outcome. Outcome is basically the target column. Okay, so based on the level of the target column, two data sets will be developed. There are two colors of will be developed. So here you can check. Now this is the advantage of this plotly. Now this is the advantage of the plotly. So if you place the cursor, it will show, okay, the glucose value is 168, corresponding age value is 54, and what is this outcome? Outcome is equal to 0. Okay, so he or she has no diabetes. Now this thing is, if glucose level is 162 and age is 54, then class level is equal to 0. Now here is the approach of Vincent Lugat. Now guys, please listen it very carefully. Now, Vincent Lugat, what he did basically, he developed several rules, to separate the feature space, to separate the feature space, or to create the local region in the feature space. Now, what is the feature space? Now, here the feature space is the glucose and the age, and this is entire one is the feature space. So, why he is considering this local region, and what is this local region? So in this case, you can see these horizontal lines and this vertical line. So if you draw the horizontal line and the vertical line, you will get a small region, and within this region, you will get large number of data points. And these data points, if you look carefully, you can say, okay, these data points belongs to class 1 or class 0. You got my point? Now, why Vincent Lugat is following a particular method? Now, thing is, if you study thoroughly the decision tree approach, the first, let us start with the decision tree. is based on the concept, and this concept is, you will find in every textbook. That is, it's saying decision tree is a non-parametric approach. Means in the decision tree, what it is doing, it is drawing the horizontal line and the vertical line, and it is finding the small region. And this small region or this local region is very, very important. Okay, I'm repeating. Now, decision tree is a non-parametric approach or non-parametric method. Divide and conquer. In every textbook, you will find the decision tree is basically top to bottom recursive programming, and it's based on the concept divide and conquer. Means it will divide the feature space one by one and it will select the local region. So I am doing the same thing. I'm following the same approach of the Vincent Lugat. What I will do, I will draw the horizontal line and the vertical line. Now, look at the beautiful presentation. Here, if you draw a horizontal line that is age below 40, and here if you draw a vertical line that is glucose level less than equal to 100, you will get maximum number of black points. Maximum number of black points. And these black points belongs to a class 0. So you can say if age is less than equal to 40 and what I could say, that is the glucose level is less than equal to 100, then the class level should be equal to 0. Yes, you will definitely get certain errors, because here you will see the 1, 2, 3, 4, 5, 6 blue points you will get, and these blue points is basically belongs to class 1. So definitely you will get some amount of error. But these type of, when you are segregating, when you are creating a local region in the feature space and you are explicitly mentioning it, then what you will do, and if you use the tree based approach like the gradient boosting method, decision tree, random forest, etc., so in that case this accuracy will enhance. Okay, now this is the fundamental concept, and this fundamental concept was used by Vincent Lugat in the KAGGLE competitions to gauge the 90.6 accuracy. So let's see. So what I am doing here, in this above scatter plot, I am just considering this one. Now, if age is less than equal to 30 and glucose level is less than equal to 120, then patient has no symptom of diabetes. So, and this rule I am considering as rule N1. And this N1, what I will do, I will keep it in a separate column in the same data frame. Now df is the data frame, so data frame dot log locations log all rows, comma, I am just mentioning the name of the column is N1 and this is the value is equal to 1. I'm giving all the values equal to 1 initially. Then what I'm doing, data frame dot log, then I am using a filtering. I'm filtering the data set. Now data frame dot log, data frame is less than equal to 30 because this is the conditions I imposed, and data frame glucose less than equal to 120, and it should be in column number N1, then its corresponding value should be equal to 0. You got my point, guys? So what I'm doing, I'm filtering all these locations from the data frame. The expressions I am giving in the data frame age less than equal to 30 and data frame glucose less than equal to 120, and I'm giving the name of the column is N1, so this is equal to 0. Okay, so this region, so 30, and here, so from here 120 to draw a vertical line, so horizontal line and vertical line, so this region you will get. Okay, so I am using the mixed constant, it is not given in the schedule. If data frame dot log data frame age greater than 30, so this is greater than 30, above this region. So below this region they were considering. So I said, okay, below this region as well as above this region, let us consider. And data frame age less than 48. So this region I am considering. You will get one data point, and I am considering is equal to 0. At the same time, I am considering data frame age greater than 63. So this is 60, above 63. So above this region. And data frame glucose less than equal to 142. So this is 150, this is 100, let us consider this is 140. So if you 138, 139, so here if you draw a vertical line, so above 63 and less than equal to 140, this one, so you will get a lot of data points, and these data points are black, so it belongs to class 0. So two extra constraints I am imposing. I'm getting a column, and this column is column number n1. This column number, or the rule number, you can consider n1. Similarly, I am getting data frame dot log n2. I'm considering another rule. Data frame dot log n2 is equal to 1. Now the conditions I am giving this data frame dot log, where the BMI value less than equal to 30. Now if it is true, then the corresponding outcome variables will be equal to 0. So what exactly I'm doing? I'm saying if age less than equal to 30 and glucose less than equal to 120, then the outcome is equal to 0. It means the patient has no diabetes. So if then rule I am imposing, and this is the fundamental concept of decision tree. This is the fundamental concept of any tree. So you will get the same concept in the gradient boosting methods, also in the random forest also, because random forest is basically what? It is a collection of all trees. What is the gradient boosting method? It is slightly different. In this gradient boosting method, what I am doing, gradient means gradient descent method you are using. It is an optimization technique. Now boosting means it is an ensemble approach. You are considering the sequence of tree, okay? And in the sequence of tree, what is this important? The thing is, you will build the tree based on the residual value, so that you could reduce the error. Residual value, residual, what is this residual? Residual is the actual value and the predicted value. The difference between the two is nothing but this error. So whether it's the gradient boosting methods like this, you can consider this group, this AdaBoost, XGBoost, NGBoost, all these terms. So you will get the same approach. The accuracy will enhance. So what you need to do, you divide the feature space, and in the feature space, you use this if then rule. I'm doing it manually here. I'm showing it what two rules I'm adding. And because of these two rules, I am getting extra accuracy or higher accuracy. Okay. So let us check next. The same way I am just plotting what is here, that is the age and the pregnancies. Age is along y-axis, pregnancies along x-axis, and the outcome, this outcome, the blue belong to class 1 and the black it belongs to 0. So here what you will check, I'm using the same rule. The first rule is given if age is, so it is 29, 28, 27, so you can find it. Now this is the advantage of the plotly. So if you press the cursor, place the cursor, you will get the coordinates. So that's why I'm using this plotly, so that you could find, okay, how you are finding this value in the if then rule. So you just use this plotly, you check the coordinate, you get the points, and you just say, yeah, okay, this is the value. So what I'm doing, so now I'm using the next rule. Now if age is less than equal to 27, you can check the cursor positions, and if pregnancy is less than equal to 6, then there is no chance of diabetes. I'm considering this is as N3 rule, and I'm adding in another extra rule. If age is greater than 60, this one, say this is 62, this is 62, greater than 60, and pregnancy greater than 7.5. So you will get a new rule N3. There's the same rule N3, and in this case, the value is equal to 0. The class value is equal to 0. So what is the purpose of this, guys? This statement df log. So it is take this, the expressions within the third bracket, and it is filtering the data set. Okay, filtering all the rows which satisfy the given constraint. Okay, and after that, what it's doing, it is assigning the 0 value, that is to the output column corresponding to that means to this row. Okay, now what I'm doing next, I am using another scatter plot. So plot underscore data frame, glucose, blood pressure, outcome. So glucose along x-axis, along y-axis you will get blood pressure, and at the same time you will get this outcome. So this is the scatter plot. So step 1, use plotly, get the coordinate, get the scatter plot, then define the rule, because once you are defining this rule, so here I am defining this rule. So data frame.log n4, that is n4, this column name is equal to 1. I am assigning on outcome values is equal to 1. Then what I am doing is data frame.log all these rows which will satisfy this one, that is glucose level less than 105 and blood pressure level less than equal to 80. Now this rule what is given, that is the glucose level less than equal to 105, glucose level less than equal to 105. So you can consider this one, you can consider this one, this is glucose level 116, so here 106, here 100 you can consider, and the blood pressure level is less than 80. So this point you can consider, the point color is 0. So if it is the point color 0, so this equation is correct, so it belongs to class 0. So if glucose level less than 105 and the blood pressure level less than equal to 80, then it belongs to class 0. Now I am refining it further. I am saying, okay, data frame.log, if glucose level less than 105 and data frame blood pressure level greater than 83, so in the same info column I am adding one constraint. I am saying, okay, this value should be equal to 0. So, and this first part, what I'm showing you, this way you need to, you know, understand the scatter plot. So this video will definitely help you to understand the use of the scatter plot. Number one. Number two, it will help you to understand what is this if then rule and why if then rule is so important to enhance the accuracy in the classification problem, particularly when you are using decision tree or tree-based model. Now, if you recall, in the decision tree, there are a lot of algorithms you will find. That is number one, CART, classification and regression tree. Number two, ID3. Number three, then that is in the ID3, you will give what is the concept. On ID3, the concept is we are basically uh, you know uh, we are using the rule-based approach, because after that, after IDC, also we have developed the decision tree algorithm based on this rule-based approach. So that's why we are using if-then rule. So whenever you are using this if-then rule, so this if-then rule is basically dividing this region to small localized portions, and these localized portions you are feeding the data, you are considering the data, and you are applying the decision tree approach. So your accuracy is enhancing. So in this next Next part, I will discuss about the different approaches that you can use. That is, number one is bagging, then random forest, then support vector classification, then you can use, extreme gradient boosting, then AdaBoost, then NGBoost, then you can use stacking. All the methods I will discuss one after another. So you please check my next presentations, and meanwhile you try to understand the what is the purpose of the scatter plot, why you should use this plotly when you are defining these rules, how plot is so handy to find out, to help you to, to find out the expressions in this if then loop, etc. So thank you very much. If you have any questions, you please ask me, or you can send your queries to my email ID.